Okay, let's just jump right in. What if? What if everything we think we know about Earth's history, well, isn't the whole story?
You mean like, maybe we weren't the first ones?
Exactly. Could there have been advanced civilizations, millions, maybe even billions of years before us?
It's a pretty mind-bending idea.
Right. So today we're doing a deep dive. We're looking at some geological clues, some scientific arguments, basically trying to see if there are any whispers left behind.
Little fingerprints in the rock, maybe?
Yeah, exactly.
Right.
Our mission is to pull out what's actually compelling here. And to start, there's this one discovery that just sounds unreal. Natural nuclear reactors, 2 billion years old.
Found right here on Earth, yeah, in Gabon.
Okay, let's unpack that. Gabon, West Africa. They find uranium ore, right? But it wasn't just like a lump of uranium.
No, not at all. It looked arranged, almost engineered, you could say. Like 17 different sites that acted like reactors.
Reactors with control mechanisms.
Yeah.
And waste. 2 billion years ago.
Yeah.
How did they even work?
Well, that's the truly fascinating part. The uranium-235, that's the fissile stuff, right? It was naturally there at about a 3% concentration.
3%? Wait, isn't that?
Exactly. That's the precise level, pretty much, that we need for our modern light water reactors to get a sustained chain reaction going.
Okay, that's spooky.
It is. And these things, they apparently produced around 100 kilowatts each. Not huge, but steady power.
For how long?
For hundreds of thousands of years. Across these 17 different spots.
Hundreds of thousands. And you're saying humanity only cracked this kind of nuclear engineering, what, 50, 60 years ago?
Something like that, yeah. So the idea that this just happened naturally.
It sounds pretty improbable. What's the official natural explanation then? How could that happen without intelligence?
Well, the standard line is a very, very unique geological fluke. You'd need the perfect uranium concentration, just the right amount of groundwater acting as a moderator, flowing in and out at the right time.
So it doesn't overheat or fizzle out.
Right. And the geological structure has to contain it all. It requires this extraordinary series of coincidences. For one site, maybe. But 17, all working so efficiently for so long.
The math starts to look pretty shaky for pure chance.
It really does, especially when you look at the byproducts, the waste, and how the fuel was consumed. It looks very much like a controlled process, not a random one. Statistically, it's negligible for it to be purely natural.
Okay, so Oklo is one really weird data point. But if there were ancient civilizations, surely something else must have survived, even with millions of years of geology grinding things down.
That's the big challenge, isn't it? Tectonic plates recycle crust, erosion wears everything away. It's immense erasure.
So what could last? This brings us to Dr. Gavin Schmidt's idea, right? The Silurian Hypothesis. Technofossils.
Exactly. The idea is maybe you don't find a fossilized city, but you find the signatures of technology, things that don't easily disappear.
Like what, for instance?
Well, think about us. We burn fossil fuels, right? That releases huge amounts of ancient carbon into the atmosphere with a very specific isotopic signature.
Okay.
So Schmidt and others suggest looking for similar signatures in the past, in ice cores, in deep sea sediments, and guess what?
They found something.
They found these sudden, massive spikes of carbon release globally with isotope ratios that look remarkably like, well, burning fossil fuels, not like volcanoes or natural cycle.
Whoa. And these spikes, do they line up with anything else interesting?
That's where it gets really chilling. Often, yes, they appear right before or during some of the planet's major mass extinction events.
Like the Permian, the Great Dying.
Precisely. The Permian extinction wiped out something like 96% of marine species, maybe 70% of land species, in what looks like less than 20,000 years. Geologically, that's instantaneous.
And natural causes alone struggle to explain that speed and totality.
It's very difficult, especially when you see these weird carbon signatures alongside it. The end Cretaceous, the one that got the dinosaurs, the end Triassic. They also show some rapid, strange patterns that aren't easily explained by just an asteroid or volcanoes alone. The speed, the selectivity sometimes, it raises questions.
So if you put Oklo together with these potential technofossil signatures and the weirdness around some extinctions, it paints a possible picture, doesn't it?
It suggests the possibility that intelligence might have arisen before us, developed significant technology, and then disappear.
Which leads to that really uncomfortable cosmic question, the Great Filter.
Exactly. The idea that there's some hurdle that most, maybe all, civilizations hit that prevents them from becoming interstellar.
Is it something that wipes them out?
That's the hypothesis. And if this evidence suggests intelligence has been here before and vanished, Well, it makes you wonder.
Did they fail the test? Is the Great Filter something all technological species face?
And crucially for us, is that filter behind us, meaning we somehow lucked out and passed it? Or is the hardest part still ahead for humanity? Maybe something related to the very technologies we develop.
So if we aren't the first, the rocks and ice beneath our feet aren't just geology. They're potentially a history book, maybe even a warning.
Written in isotopes and extinction layers, yeah. Cautionary tales.
The ultimate question then becomes, for you listening, can we actually learn from these faint ancient echoes? Can we read the warnings in the chemistry of the past to navigate our own future climate change, advanced AI, biotech, whatever the next big challenge is?
Or will we just become another thin layer in the rock, another brief spike in the carbon record for someone else to find maybe billions of years from now?
A profound thought to end on. Will we pass the test?